Stanford University.
All right, guys, welcome to CS 193P Lecture 8. Today we've got some really exciting new stuff to talk about. That's, of course, scroll views and table views. It's pretty sweet. I'm not sure if you've seen it, but they're pretty exciting. So let's start off with scroll views. We're going to talk about that for a little bit. As you can see, scroll views start out up on the screen there, and you can swipe between your icons with them. So that's pretty cool. So, all right, no, but seriously. I'm sure everyone has some questions about what's going on with this. We're going to try and head off some of the questions before we get too far in. So let's start out talking about the SDK just a little bit. As we announced yesterday, iPhone OS SDK 3.2 is the SDK that supports development on iPad. It is a beta release available from developer.apple.com, and it's available to members of the standard and enterprise developer programs. That does not include the university developer program or the free online developer program. If you want to download the iPad SDK, you can definitely do it today for the $99 standard developer program. Yes, so enrollment in the developer standard or enterprise is required. Nevertheless, we have sort of surreptitiously been talking about iPad development all semester so far, and we'll continue to do so through to the end. Everything we've been talking about is absolutely applicable. Everything you're learning, if you're using view controllers and setting up your application using view controllers to be modular and keeping everything together in a single view controller, sort of encapsulated there so that they fit together and work with each other the way we talked about last week. All that stuff is a great start to iPad development, and you'll be able to take those things and make good use of them when you can. Sure, what's up?
Do we get extra credit on our final project if we utilize the capabilities?
Do you get extra credit on the final project for utilizing the capabilities? We're still figuring out the story for final project regarding iPad development. We've traditionally not wanted final projects that were simulator only. And obviously final project is going to be due before the 60 days and 90 days for the iPad release. So we'll get back to you on that. We're figuring it out. Yeah, what's up?
Did we know about this?
Did I know about this? I'm not sure what we can really say about.
I think John's been working on it for years.
Yeah, it's. I mean, we've all been. There's a ton of, a lot of people at Apple that have been working really hard on this. So, we're very excited that everyone gets to see it, and we're really looking forward to 60 days from now when you can all get one and try it out. And it's been a lot of fun, and now that we can talk about it a little bit, it's pretty cool. Yeah.
Who came up with the name?
Who came up with the name? I can't talk about names or anything like that. Yeah. All right, sorry. Any other questions about this before we actually get into what we're going to talk about today? Okay. So announcement first, the Presence 1 assignment is now posted on the website. It's at...
Paparazzi. We changed it.
How did I call that again? I keep saying it and calling it and everything. The Paparazzi 1 assignment, sorry, is now posted on the website. It's due next Wednesday, and we talked about it a bit and saw some screenshots of what it would look like on Tuesday, actually. So definitely go check that out and get started. If you have any questions, we'll, of course, be able to talk about it again on Tuesday in office hours. So today, we're going to cover scroll views and table views. Scroll views are the solution, the answer to the problem. I've got a lot of content, and it's more than is going to fit on this really small iPhone screen, or even a larger screen. And how do I display this large amount of content to the users? So scroll view is the answer to that. UIKit actually also provides a couple of standard subclasses. UI table view is a very common one. You'll see it throughout the iPhone user interface. It's a subclass of UI scroll view and provides some extra functionality on top of just UI scroll view by itself. We'll be using it in the projects, and you'll see it a lot. It's a very common interface element throughout all of the iPhone applications. So we'll talk about how to display data with a table view, and we'll talk about how to control the appearance and behavior of the table view. Then we'll talk about UI table view controller, This is a subclass of UI view controller, just like the navigation controller and tab bar controller. We've talked about manage navigation bars and tab bars. UI table view controller is a standard subclass for managing a table view. And then we've got table view cells. We'll finish with that. It's table view cell is basically the UI view subclass that UI table view uses to display data inside of itself. So we'll talk about how you can get those, create them, customize them, get your data inside of them and looking exactly the way you want it to look. And I got presents again. Sorry. All right. So let's start out talking about UI scroll view. So first off, as I mentioned, UI scroll view is used for displaying more content than you can fit on the screen, or perhaps more content than you can fit in memory. If you've got, for example, the Maps application has just huge amounts of data. It's well beyond what you could even store on the flash on the phone itself. So it actually pulls data as necessary off of the internet. And UI scroll view is the class that's used in order to manage scrolling around within that, panning around the map, zooming in. And so we'll talk about that a bit. As I mentioned, scroll view handles these gestures for you. So all of the behaviors that you get in the standard iPhone applications for panning around in content, like in Safari and Maps, and zooming in and out with a pinch gesture, UI scroll view implements those gestures and handles detecting and responding to them for you, so you don't have to implement all the code to detect these different multi-touch gestures on your own. As I mentioned also, one of the noteworthy subclasses is UI table view. We've got another one called UI text view, which is used for displaying large amounts of text. There's also UI web view, although that's not a subclass of UI scroll view directly. It does use a UI scroll view in displaying the web content. So it's also used there. So some examples of where you'll see this already on the phone. As I mentioned, Maps has a scroll view for displaying the map. The Photos application uses multiple scroll views. There's an outer scroll view that's used for panning between multiple pictures. So you can swipe left and right, and you'll basically page through all your individual pictures. And then if you pinch in on an individual picture, it would be using a separate scroll view embedded inside of that to zoom and scale the content up and down. The UI text view subclass that I talked about is what would be used in something like Notes to display all your text. And it's also editable. This is an example of a UI table view. There's a lot of different appearances you can get. A lot of things that you might not even necessarily think are table views actually can be implemented and are implemented using UI table view. I don't really have a lot of other examples of that right now, but some of the things that come to mind are the Photos application itself, the initial view of Photos where you've got a bunch of thumbnails of your images. Each one of those rows in the list of thumbnails is a separate table view cell in a UI table view. So we'll talk about this a little more later. UI table view really only by itself, by default, handles a single column worth of data. You could actually do multiple columns of that nature by managing the layout of things in the cell yourself. And finally, the Clocks application it's another pretty good example of something that's done with UI table view, but has a very custom appearance that looks like really nothing else on the phone. Each of the individual clocks there is actually a separate UI table view cell inside of a UI table view. And they just have, it's table view cells that have been customized to have this different appearance. So we'll talk about how you can customize them and get things to look just like that. All right, so that's basically the idea of what a UI scroll view is and what UI table view looks like. So let's talk about some of the pieces that make it up and what you have to do to actually scroll your content. So this is the view in Photos I was just talking about. But let's imagine that we were implementing this ourselves and we weren't using a UI table view. We just were going to use a UI scroll view with a big view in it that had a bunch of photos. So you actually only have to do two things in order to make this content scrollable. So first of all, you want to add this as a subview of your UI scroll view. And second, you want to set the content size on your UI scroll view. So content size is the width and height of the content, basically the amount that you need to be able to scroll in order to see everything. So content size.width is the width of the content. Content size.height is the height. Content size now it's a property on UI scroll view, and it's a CG size, which is one of those classes defined by core graphics. Sorry, not classes. Structures defined by core graphics that we talked about earlier. So that defines the width and height of your scrollable content. But there may be cases where you want to add some extra area that can be scrolled above and below. And you could do that just by extending the content size. That's certainly one way. But another option, and something that's slightly more dynamic, is another property on UI scroll view called content inset. Now, content inset just increases the amount of area that can be scrolled either on the top, left, bottom, or right of the content that you've specified with content size. So in this case, we've specified a content inset on the top and a content inset on the bottom, which just adds a little bit more scrollable area up above and below the content that we specified with our content size. You might be wondering why you'd want to do that, and it probably doesn't make a whole lot of sense right here, but let's put this in an iPhone where it's going to start to make a little bit more sense, and it'll be clear. So this is a pretty interesting interface. I mean, we're using the entire screen to show all our content, and that's pretty great, but it's very infrequent that you'll be able to do this without having some sort of controls visible at some point in the application. So in the example of the photos here, we actually need to have some navigation bar and a status bar visible to add the controls and the time, and we want all that available for our users. But once we've shown that, now we're covering up some of our content. So if we set a content inset on the top, that gives us the extra scrollable space we need to be able to scroll that down below the stuff that's on the top of the screen. Same thing for the toolbar down at the bottom. We can set a content inset on the bottom, which will allow that content to scroll all the way up above it, but still be able to scroll underneath it. So our scroll view is still sized to the full height and width of the screen, and just has these content insets to allow the content to have some extra space so it can get above the other interface elements. All right, so one last bit that we want to cover about that is a standard part of UI scroll view are these scroll indicators. I'm sure you've seen these as you've been using different applications on the iPhone already. As you're scrolling scrollable content in a UI scroll view, while you're scrolling, there's a little indicator that appears either on the right-hand side if you're scrolling vertically or on the bottom if you're scrolling horizontally to give you an indication of how far into the content you are and how much more there is to go. So by default, those indicators are created by UI scroll view and will scroll. They'll show up anywhere from the top of the scroll view's visible bounds all the way to the bottom. But in this case, we just said the scroll view's visible bounds take up the entire screen. So those indicators are going to start out all the way at the top underneath the status bar and the navigation bar, which we don't really want. So there's another property called scroll indicator insets, which allows you to shift that down. So if we set the scroll indicator inset.top, that'll set the maximum point, or rather the minimum point, where that scroll indicator will scroll up to down a little bit below these other interface elements. All right, so that's kind of how we set it all up. But in your application, you may sometimes want to know exactly where in the content you're currently scrolled to. And scroll view actually tracks that itself in a property called content offset, and you can both get and set it yourself, either animated or not. Now, content offset is it's the point in your content that's currently visible at the top left of the scroll view's bounds. So you can see in this case, the point that's currently visible is at the top left of our iPhone there. So our content offset is the height of the amount that's up above. It's the point in the content visible at the top left of the scroll view's bounds. All right, so let's put this all together and take a look in a bigger picture. So here we've got an image, and so our content size.width and height are the width and height of our image, assuming that this image is being displayed in a UI image view that's exactly the size of the content. We want to give some padding around the edges, so we have content inset left, top, right, and bottom all set, and in this case they're probably all about the same. They could be different values. And that's the basic setup to get something scrolling in the UI scroll view. So let's kind of gray out everything other than what's visible in our scroll view and take a look at content offset in this case where we're scrolling both horizontally and vertically. Now, as I said, content offset is the point that's currently visible at the top left of the scroll view's bounds. So in this case, that's that point in our content right there at the top left of our area that's not grayed out. That's what's currently visible. So content offset, the point in the content visible at the top left of the scroll view's bounds. Now, you'll notice that's starting from not the top left of the content insets, but the top left of the content. So an interesting point about that, it comes up when we actually scroll so that everything is visible. If we bring those content insets into the visible area, now the point at the top left of our content visible at the top left of the content of the scroll view's bounds is actually now inside of the scroll view. So if you're using content insets, it's actually valid for there to be negative content offset. And in this case, the content offset would be negative content inset left and negative content inset top. All right, so that's pretty much all you need to know. There's more there than you actually need to just get started. To really just get started, you just need to add your subview and set content size. So let's take a look at what that'll actually look like in code. The first thing you want to do is create your UI scroll view. You can either do this in Interface Builder or you can do it programmatically. It's just a subclass of UI view, and it uses the same designated initializer, init with frame. So we'll create our frame here, cgrect make 00 200 200, and we'll call UI scroll view alloc init with frame frame. Then we'll add that as a subview to our view, and we'll add some other content view as a subview to it. So maybe we'll have a UI image view that we want to pan around inside of our UI scroll view. So we'll allocate that and put it inside. The frames of your subviews can actually extend beyond the bounds of the UI scroll view. This is pretty much the whole point of the UI scroll view to begin with. So the visible frame of your scroll view may only be 0, 0, 200, 200. It's a 200 pixel by 200 pixel square, but its subviews can be way outside of that. And anything that's outside obviously isn't going to be displayed. It's outside of the bounds. As the user scrolls around, different parts will move in. So in this case, we're going to allocate an image view that's 500 pixels by 500 pixels, significantly larger than the scroll view that's going to contain it. We'll allocate it with that frame, and we'll add it as a subview to the scroll view we just allocated. And the last thing we have to do is set the content size of that scroll view. So those are the two things. Allocate the scroll view, or sorry, three things. Allocate the scroll view, allocate the subview, and add it as a subview, and then set the content size. So in this case, we're going to set the content size to the exact same size as the image view we just added. You could do more complicated things if you wanted. You could actually have two image views side by side, and your content size could be the sum of the width of the two of them. It doesn't necessarily have to be just one subview, but that's sort of the simple case, and that's what we'll do here. All right, so that's really all you have to do to get scrolling to work. Once you've done that, your users will be able to put their finger down and move it around, and the content will just track it. It follows exactly. Whatever you put your finger on is what stays under your finger while the user's moving it around. So that's the basics, but there may be some cases where you want to extend the behavior of the UI scroll view. And other languages tend to do this kind of thing in a different way than what we do. So we'll talk a little bit about how we would do it in UIKit. So what might we want to do this for, though? You often want to know about scroll events. You want to know when the user starts scrolling. You want to know when the content offset is changing. You might want to know when the user lifts their finger, whether the scroll view is going to decelerate or just stop. If you have used an iPhone for a while, you I'm sure have noticed by now that if you flick a long list, that's a UI scroll view. And if you flick it, it doesn't come to rest immediately. It actually decelerates and lands somewhere a little further down. So there's a notification that we'll see in a bit that for when the user's finger is lifted and when that comes to rest. So that's dragging beginning and ending is while the finger's down, and then deceleration is while it's actually slowing down. So the way other languages tend to deal with this kind of thing is generally through subclassing. You would have some complicated superclass, and you'd subclass it and override some methods and change the behavior that way. In UIKit, we don't really like to do that because there's actually a couple of reasons. So first of all, the application logic and behavior then becomes part of the view itself. Like you may have some custom scrolling logic that you only care about in one view controller, but you want to reuse your scroll view in multiple different places. If you had to subclass it for every different one, you'd end up with a lot of different subclasses of scroll view and specific application logic in the views when we're really trying to maintain this model view controller paradigm where the controller is the thing that's determining the application logic. So it kind of breaks that if we were to do the subclassing approach. It's also pretty tedious to write a lot of these subclasses. You end up with a lot of separate views that aren't reusable. And a big point of the view part of model view controller is that the views are reusable with different controllers and different models. So if we put all the logic in the view, it reduces the reusability and makes it pretty tedious to do all of this. And also your code then becomes very tightly coupled. And that's basically the same as what we just said. It becomes part of the superclass, really. You can't really extract it from UI scroll view and replace that with something else later. If it's in your controller and part of your model, it's easier to, sorry, not part of your model, part of your controller. It's easier to change the way it works later and rearrange parts of your app. So what we like to do in UIKit is use a pattern called delegation. And this is actually something that's been part of Objective-C for a very long time. It's a pretty standard practice. So we talked briefly about protocols in Objective-C early on in the first or second lecture when we talked about the basics of Obj-C. And I mentioned that we would talk about it more when we got to delegation. So this is really where it comes back. The delegate is a separate object. So if you have your scroll view, the scroll view will have a delegate. And it's some other object. And generally speaking, it's probably your controller object. The protocol, the Objective-C protocol that defines the set of methods that the delegate will implement, basically it creates a very clear defined set of override points where you can customize behavior or customize appearance. It's not quite as open-ended as subclassing, where the subclass might go ahead and change anything on the superclass. There's a very clear, defined set of points where you can change behavior and change appearance. And one of the benefits of this is that it maintains a loose coupling between these objects. The view itself and the view controller, or whatever other controller object is the delegate, isn't a direct subclass of the scroll view, and it's a bit more loosely coupled than the tight coupling of the subclassing. So what does the scroll view delegate look like? Well, it's a protocol, as I mentioned, an Objective-C protocol. I don't think we've really seen this yet. So a protocol is declared like this in a header file. It's at protocol, again, with the at symbol, UI scroll view delegate. And this is another construct we haven't really seen, are these square brackets, the angled brackets, which that defines, I'm forgetting the term, that a particular class implements conforms to a particular protocol. Conforms to is what I was going for. So in this case, we're saying that the UI scroll view delegate protocol conforms to the NS object protocol. So any object that's going to be set as a UI scroll view delegate must also conform to NS object, which for the purposes of what we're dealing with, everything conforms to NS object. But that's how you would write it if you were to say that it conformed to some other protocol as well. You can have methods in your protocol that are either optional or required, and the compiler will actually warn you if you claim that you conform to a protocol but don't implement all of its required methods. Optional methods it won't warn you about because they're optional, so you may or may not implement them. It's kind of up to you, but you do have to implement any required methods. The scroll view UI scroll view delegate specifically has actually quite a lot of delegate methods. We won't go over all of them because there's too many to cover right now. But one of the interesting ones is scroll view did scroll. This is called every time the scroll view's content offset changes. So as the user is moving their finger around, this method is getting called constantly. One of the interesting things that lets you do is have subviews in your scroll view that can, for instance, get pinned to an edge when they get there. So actually, if you have looked at the address book application on the iPhone or iPod Touch, there's headers at the top of each of the sections. So we'll get into what sections are in just a minute. But they basically float. As they hit the top of the screen, they stop there until the entire section scrolls off, and then they move off. This is done by, at every change in the scroll view's content offset, shifting that subview down a little bit so that the effect is that it seems to stay in place. And you can do that kind of thing using the scroll view did scroll delegate method. So that's an example of responding to events. The other thing that I said you might do with delegates is influence behavior. And an example of that in the scroll view delegate protocol is the scroll view should scroll to the top delegate method. This is a little bit hidden. Not everyone knows that it exists. But in any scroll view, when you see it on your iPhone screen, if you're not scrolled all the way to the top of the scroll view, you can tap in the status bar, and the scroll view that's visible will scroll all the way to the top. That's the default behavior. You can turn it off by returning no from scroll view should scroll to top. All right, so there's actually, as I mentioned, quite a few other delegate methods, and you can check out uiscrollview.h where you can see all of them. But let's take a look at implementing one of these things. So first of all, we have to declare that we conform to the protocol. So in this case, we have our controller, my controller. It's a subclass of NS object. This could also be a subclass of UI view controller if we were implementing a view controller. And we're going to declare that we conform to the UI scroll view delegate protocol by putting that after our superclass in angled braces there. At that point, we then have to, as I said, implement all the required methods and any of the optional methods. So in this case, we'll implement scroll view did scroll. Actually, scroll view has no required methods in its protocol. They're all optional. So you don't actually have to implement anything. So we'll implement the scroll view did scroll method. And we'll do something if scroll view's content offset change. We may move something around, or you can respond to scrolling in any way that you might like. You probably don't want to do anything too compute intensive in this particular method because, as I mentioned, it's called every time the content offset changes, so it's continuously while the user is scrolling around. So you want to try and be not too heavyweight in your computation in here, or else the user experience will get pretty bad and scrolling will be pretty choppy. So that's the basic idea. One of the other things that I mentioned scroll view does for you is it allows you to zoom in and out on your content, and it handles most of this for you. There's actually only two things you have to do. And I left it till the end because it requires a little bit of information about the delegate. The first thing that you have to do is set a minimum and or maximum zoom scale. The important thing about this is just that you have one of either of these set to something other than 1.0. You're defining the range of scales that are valid for the content. So the default for both is 1.0, which basically says that normally you can't zoom in or out on the content. So in this case, we'll set our maximum zoom scale to 2.0, so we can have our content scale up to twice its normal size. And we'll set the minimum zoom scale to the scroll view's width divided by the image view's width. So the scroll view's bounds width, or frame width, sorry. So basically, that fraction is the fraction that you would need to perfectly fit your content horizontally within the scroll view. So we can zoom down such that the content fits exactly horizontally in the scroll view. Maybe it still needs to scroll vertically. So that's the first thing you have to do. The second thing you have to do is implement one delegate method, view for zooming in scroll view. And this requires that you return some subview of your UI scroll view that the scroll view will zoom up and down. When we talked about UI views, we talked about how a view has a transform property that allows you to have a rotation, a scale, or a translation on any view. The view that you return from view for zooming in scroll view will have its transform property set to a scale that corresponds to the scroll view scale. So as you're pinching, scroll view is setting the transform property on whatever subview you return from here to make it bigger and smaller. There's a couple of new methods in iPhone OS 3.0 that allow you to handle some of these things programmatically. Prior to that, in iPhone OS 2.0, the scroll view pinching allowed you to have users pinch in and out, but you couldn't in your code set the current zoom scale. So now in 3.0, we have set zoom scale animated, which can either animated or not adjust the zoom scale to any scale that you like within the minimum and maximum range. So if we do that, you're going to see it's going to zoom in and out around the center of what's currently visible in the scroll view. So you can see it's sort of zooming in and out around the center of that image. That's super easy to implement. I mean, you just provide one scale, it's one number, it's really easy. But it may not provide quite enough control for you. You don't really get to decide what's going to become visible, and you can't really control which point it's going to zoom around. So there's another method that gives you a little bit more control called zoom to rect animated. This lets you provide a rect specified in your content view's coordinate space, so some rectangle inside the bounds of your zoom view. The rectangle that you want to become visible after the zooming, and scroll view will calculate the zoom scale necessary to make that happen and fit it as best it can, again taking into account the minimum and maximum zoom scale. So in this case, if we picked that rectangle there around the dragon's face and called zoom to rect animated with that rect, it would zoom it up to fit it as best it can within the visible bounds. Similarly, if our content was already too big, we specified a really big rectangle outside of what's visible, it would scale it down to fit in as best it can around there. And again, it'll try and change the content offset the smallest amount that it has to get that to fit fully within the frame. So it won't necessarily zoom around the center like set zoom scale would. All right, so that's the basic idea. Let's take a quick look at what some of this looks like when we actually implement it. So let's start out with a new view-based application. That's going to give us a view controller by default. Normally, in the past, we've been starting with window-based applications, but let's go ahead and create a view controller this time. Let's scroll an iPad here. So I've conveniently already prepared an image that we can zoom and scroll. Let's get that in our resources. And let's start out with our view controller. So actually, since we created this using that default template, one of the things we got from that was, one of these here. Our view controller came with a nib. So right off the bat, we already have a nib. So let's actually edit that nib and delete the default view that it gave us and replace it with a scroll view. So our view controller's view is actually going to start out being a scroll view instead of that default view. So we'll get that out of there and drag it in here. We have to remember that when we replace the view controller's view in a nib, we have to hook it up. So files owner, which is our view controller, needs to have its view outlet connected. So we'll connect that. And we'll also hook up the delegate for the scroll view just so that we can implement some of those methods. So we'll control drag from the scroll view back to files owner and set up the delegate. All right, so now if we open up our view controller class, we can go ahead and go to load view, or sorry, view did load. Man, not cooperating here. And we're going to create a UI image view. We could have done this in IB, but we'll do it programmatically just to be clear about how it's all working. And we're going to do init with image. But yeah. Of course, before we can init with an image, we need an image. So we're going to get a UI image. And we'll use that UI image image named method that we saw, which returns an auto-released UI image. And I forget what I called that image, so let's find out. Yeah, where did it go? Let's find it in here. Oh, yeah, it's right there. All right. Oh, it's a JPEG. That's why I wasn't finding it. So our image was named. Well, I just copied it off the internet, so it's got kind of an interesting name there. So now we've got our image, so we'll initialize our UI image view with that image. We'll get self.view and add subview that image view. One of the things that image view does is when you init with an image, it sets its frame to have a size equivalent to the image's size. So it's already sized to perfectly fit the image. Then we can actually want to hang on to that UI image view because we're going to return it from view for zooming and scroll view a little bit later. So instead of declaring that there, let's put it in our header. And then we'll keep the pointer to it and find our dealloc and release it. Not call dealloc on it like I did last time. What did I do? That's what we're trying to do. We're trying to release the image view, not the scroll view. The scroll view is the view controller's view, so it's being retained already by the view controller. And oh, I see what I did. Right. Thanks. Man, I have really screwed this one up. UI image. Get some ordering correctly. This time for sure. All right, and the last thing we didn't do is set the scroll view's content size, right? We have to add this image view as a subview and then set the content size. So self.view is our scroll view because we set that up in IB. It's not typed to that though, so we're going to have to cast it. It's a little gross. Maybe not the best thing to be demonstrating, but we'll do that. And we'll call set content size, and we'll set it to the image's size. We've got the image, we can ask it how big it is. So we can set that. So now if we build and run, we've got a scroll view that has our image in it, and we can already scroll around in it. Can't quite see the bottom, so let's turn it on the side. We've got the scroll indicators going on the bottom and the left. We're bouncing as we get to the edges. That's all default behavior, although it can be customized. You can change that. And really not very much code, and we can already scroll around in something. So let's add zooming. It's really only two things, as we mentioned. Copy this line here. Let's set our maximum zoom scale to 2.0. And, well, let's just do that. And then let's also implement the view for zooming and scroll view method. I should have just copied this. But I'll type it. And we'll return the image view that we just stashed away. So with that done, we can still scroll around. But now if we hold down the Option key in the simulator, we get these 2 points that sort of correspond to 2 fingers. And they just move around centered around the center of the simulator. So now if we click and drag, we can actually scale that content up. So really only 2 things, and now we've got both zooming and scrolling. Cool. All right, so that's the basics, that all of the other scrollable content on the iPhone is built around. UI table view is the next class we're going to talk about, and as I mentioned, it's actually a subclass of UI scroll view. It actually manages setting the content size for you based on some other information that it gets, which we'll talk about in just a little bit. So you don't have to worry about setting the content size specifically when you work with UI table view. It handles that case. The other example that we talked about is UI text view, which also deals with the content size automatically. Just allows you to give it a bunch of text, and it can display it for you. So let's start out with UI table view. Table views display large lists of... Oh, yeah, what's up?
Sorry, for the scroll views, you know, sometimes when you zoom out, it's blurry, but then it refines, it improves the graphics. So is it doing that automatically, or can you load images, cache images?
So the question is, when you've got a UI scroll view and you zoom out, it gets blurry, or zoom in rather, I guess. It gets blurry for a little bit and then sometimes cleans itself up and gets, smooth again. It redraws at a new resolution. Do we get that automatically? And the answer is no, you actually don't get that automatically. All that the scroll view is doing while it's zooming, as I mentioned, is setting the transform on the view that you're zooming. And when you're setting the transform, all that's doing is telling Core Animation to draw it at a bigger scale. So it doesn't have any more data to provide a higher resolution image unless you've provided that image to begin with. So you could actually, one of the things you might do, there's another delegate method that tells you when zooming has finished. At that point, you could swap the image in your image view out for a higher resolution image, something more appropriate to whatever the current final zoom scale is. And that'll give you the opportunity to effectively redraw it yourself. If you're doing something with DrawRect, it's a little bit more complicated because in that case, you're still just setting the transform on the view, and there's no way to tell a UI view that it should draw with a higher resolution backing store, which is what you'd need in order to actually have that get clearer. So if you're zooming a DrawRect view, the answer is a bit more complicated. There's actually some samples of that available through the developer.apple.com sample code site in a project called Scroll View Suite, which does some rather complicated things, actually. It does both tiling of content that basically lets you load parts of an image at a time and only load the pieces you need, basically the kind of thing Maps does. And it also deals with swapping those out with higher resolution versions once you've zoomed in further. So if you really, it's a pretty advanced technique, I guess, certainly beyond what we have time to talk about here. But if you want to know more about it, it's a great sample, and it really covers it pretty well. The other option for that is a class called CA tiled layer. We won't really get into the specifics of how you replace the layer that backs a UI view in this class, but there's plenty of examples of how you would use a CA tile layer to do this. And it actually does let you implement DrawRect, and it handles the swapping out of backing stores with higher resolution backing stores for you. So if you use a CA tiled layer to implement your DrawRect view that you have in your scroll view zooming it, that's actually taken care of mostly for you. It's not something that we have set up to be sort of a drag-out, readily available thing in Interface Builder, but it's absolutely possible to do. There's definitely samples available for that too.
Would the layering approach be better performance?
The question is, would the layering approach be better performance? The performance it's going to depend a bit on the specifics of your content, I guess. A lot of it's going to depend on how much you have to load into memory and how you manage that, because there's pretty limited memory devices, and if you're loading a ton of content, that's going to be your gating factor. As far as whether using the layer with the DrawRect or using subviews is going to be faster, it's hard to say. It depends on what exactly you're trying to optimize for, I guess. Scrolling is probably faster with the view-based approach, and zooming is probably faster with the CA layer-based approach, but they're roughly going to be equivalent. Okay, so table views. They display large amounts of data. That's what they're really designed and optimized for. They've been tested with tens of thousands of rows. They're definitely optimized for displaying large quantities of data. They're vertically scrolling. They don't support horizontal scrolling, just a vertical list. And to that end, they're only single column. They don't really have built-in support for multiple columns of data because they're really limited to the width of the device. And as I said, large data sets. They're quite powerful, and they're pretty ubiquitous, as we talked about earlier. We saw a few screenshots of places where they're used, and they're really flexible. With the individual table view cells, which is what is used to display an individual row, you can add arbitrary subviews to that and do whatever kind of custom drawing or anything you want. As long as you've already learned how to deal with UI views in general to do custom drawing and add subviews and all that, that all applies directly to UI table view and UI table view cell. You can customize them that way and pretty much make them look like anything you want. So they're really quite powerful and very customizable. There's two basic default built-in styles for UI table view. The first is the plain style, which is actually used pretty much throughout iPhone OS. It's used in a lot of places. The plain style basically just means the table view by itself doesn't really provide a whole lot of appearance before you've actually provided any yourself. For the most part, the only thing that it's going to do, it'll give you those section headers and footers. You see there, the section header has the section F up at the top, And as I was talking about before, it's currently pinned to the top of the screen. Even as you're scrolling that content, the section header F stays up there until all the F content moves off, and then it scrolls off. Table view also provides this index bar that you see on the right, and that's really only for use in the plain style table view. So you can get that. The group style table view is the other default style that UIKit provides, and it gives you this kind of like rounded section segmented look. Each of these separate, basically the appearance that you see here is defined by the group style table view. It's this vertically striped background with the white sort of circular segments over top of it. And you get that kind of appearance by default with UI table view style grouped. So those are the two basic styles. Let's take a look at the different pieces that actually make up a table view. So here we've got an entire table view and all of the parts that might compose it. At the top, we have a table header. This is optional. It's a property on UI table view that you can set, and it's just a UI view. So you can create any UI view subclass or use just a UI image view or a UI label, allocate it, and set it as the table view's table header view. And the table view will position it above the rest of your content, and it'll scroll up and down with the content. At the base of the table view's content, we've got the table footer view. Again, just any subclass of UI view. It's a property on UI table view that you set. And the table view will position it below the rest of your content. Between the table header and footer views are the sections. And you can have multiple sections. In this case, we've got two. The one that we're highlighting here is the bottom one, and then we've got one above. The sections appear between those table header and footer view. Sections are composed of a section header and a section footer. These are not properties on the table view, and we'll get into a little bit more later about why that's the case, but basically you might have any number of them because you can have an arbitrary number of sections. So they can't just be a property that you'd set because you need to be able to provide a large number of them at some point, and we'll talk about that in just a second. So there's a section header and a section footer, and then between the section header and footer are all the individual cells. And this is the table view cell thing I was talking about that you can really customize and where a lot of the real customization power comes in. And so each of the rows is represented by a separate table cell. So that's the plain style. If we take a look at the same different pieces of a table view in group style, they're basically the exact same thing. They're just slightly shifted. So this is everything put together for plain style. In group style, all the exact same pieces. They have slightly different appearances, and the appearance has actually changed the size a little bit. Some things have shifted a little, but they're all the exact same pieces. We've got the table header and footer, section header and footer, and table cells in between those. The table cells that are at the top and bottom of a particular section automatically get the rounded top and bottom corners. The ones that are between them, they're not rounded so that it looks like the entire section fits as one piece. And so that's the group style. It's basically the same thing. So how are we going to use these things? We want to display our data in the table view, and we want to customize its appearance, and we want to customize its behavior. So there's really two separate topics to discuss here. It's first off, putting the data in the table view, and second off, customizing its appearance. And this is going to use the same delegate type protocol we just talked about. And additionally, we're going to be talking about a very similar thing called a data source protocol. It's effectively the same exact concept as a delegate, except that the point of a data source is to have another object that provides data to a particular class, in this case table view. Rather than customizing its appearance and behavior, it actually provides data. So that's the data source. So let's take a look at that. Displaying data in our UI table view. So a really naive solution, a really basic thing we could just very easily slap together and be on our way would be start out with a method on UI table view called setList, my list of stuff. And we could just have some NS array that contained a bunch of stuff that the table view would just display. We don't do this, and this method doesn't even exist because it's got some pretty significant drawbacks. The first of which is it would require all data to be loaded up front. If we had hundreds or thousands of cells, you'd have to load all the data for all those things right away and give it to the table view. It'd be incredibly inefficient. Memory usage would be terrible. You probably couldn't even fit all of it in memory. So we don't do that. What we actually do is go for this more flexible solution we were talking about, the data source protocol. So we have another object that helps out the table view by providing it with data. And in this case, keeping in mind our model view controller paradigm, table view is the view, controller is probably the data source providing the data for the view and getting it from the model. It's not fetched all at once, so table view won't ask the data source for all 10,000 rows right at the beginning. It'll just ask for the 10 that are visible. just gets what's needed for display right now. Like the delegate, it's purely data oriented. It's just asking the data source for the data. So that's declared with the UI table view data source protocol. It's another Objective-C protocol, so add protocol UI table view data source. It provides a number of sections and a number of rows are the first two methods that you can implement. The first one is actually optional. Number of sections in table view lets you specify how many of those sections we were just talking about your table view should have. The default, if you don't implement it, is 1, so you don't actually have to implement that unless you need more than one section. And then there's a required method, table view number of rows in section. And that allows the table view to ask its data source how many rows should be displayed in a particular section in the table view. So you obviously do need to implement that, or else the table view would have no idea how many rows it should display. It's in the protocol, it's declared in the at required block, so the compiler will actually warn you if you haven't implemented it. So that tells the table view how much to display. We also need a method to tell the table view what to display. So for that, we have table view cell for row at index path. This is also a required method because otherwise there wouldn't be any way for the table view to draw anything. The thing that you return from this is an instance of a UI table view cell. And a UI table view cell is a subclass of UI view that has some special knowledge about how to behave properly and participate in the table views, scrolling and all of these things we just were talking about. It knows how to draw the grouped backgrounds for the group style table view. So it has to be a subclass of, well, a UI table view cell itself or a subclass of UI table view cell that you return from this method. And we'll get into what those look like in just a second. But first, let's take a sort of more visual look at what this all means with the data source message flow. So we've got our UI table view over on the left there, and we've got our data source on the right. The first thing that the table view needs to know is how many sections it has. So it's going to find out, hey, data source, how many sections do I have? And the data source is going to say, well, I got 5, and it'll return 5. So once it knows that, then it has to figure out how many rows there are in each of the sections that it has. So it knows how big the content's going to be. So it's going to ask the data source, how many rows are there in section 0? Data source is going to say, well, 1 row in section 0. Return that. It'll do the same for all the other sections in the table view, filling out how many there are in each one. Once it's got all that, it needs to know, what do I display in section 0 at row 0? And so on and so forth for the rest. Section 1 at row 0, section 2 at row 0, 2 at row 1. It'll ask for everything, but only the things that are visible. This is the lazy part, and the part that's really much better than just providing the big raw list of data, is we can be very lazy about it and efficient and only ask for the things that are needed to display things right now. So it'll ask what to display at section 0, row 0. Data source returns one of these UI table view cells we just talked about. And in this case, it'll have the text John Appleseed in it. All right. There's one class we have to talk about before we can actually use this. And this is another class provided by the Foundation Framework. And we've been talking about the Foundation Framework all along. It's the thing that provides NSArray, NS Dictionary, all these base objects. There's another one we haven't mentioned, and that's NS Index Path. And it's actually just a generic class in Foundation that provides basically a path to a specific node in a tree of nested arrays. You know, that's kind of a weird way to say it. Effectively, it's an array of integers is basically what it is. And table view uses this to represent a particular row in a particular section. So all index paths that UI table view uses have exactly 2 elements in them. The first one is the section, and the second one is the row. And there's actually some convenience methods defined on NS index path that can help you with that. So the first one is NS index path for row in section, which is a convenience method that returns an auto-released NS index path representing a particular row and a particular section. And then you can also, there's properties to ask a particular index path for its section and row. So that's how you represent a particular row in your table view. So let's take a look at a single section table view. First off, it has to return the number of rows in the table view number of rows in section method. So let's say we have an array, myStrings, just an array of strings. We'll get the count of those and return that from our number of rows in section. In this case, we haven't implemented number of sections in table view because we only want one section, and the default implementation just returns 1. Next, we need to provide a cell when we're asked for it. So we'll implement table view cell for row at index path. The first thing we have to do is get a cell, and we'll look a little more closely at that in just a second. Then we fill out its content. So a cell has a text label, which draws the text in the cell. So we'll call cell.textlabel.text and set the label's text to the string at the index path row that we're being asked about. There's only one section, so we don't have to check what section that index path is asking about. We really only care about what row it's in. So indexPath.row tells us which one we're being asked for, and we can get the object from our string array at that index and set it to the text labels text. And we'll return the auto-released cell so that we basically turn over memory management to the table view. So I kind of glossed over right there how we're going to get that table view cell. There's a pretty interesting concept, and actually an incredibly important concept to table view performance, called cell reuse. One of the most expensive operations involved with table view scrolling is the creation and destruction of all of the individual cells. So if you flicked really fast and you had to scroll through hundreds of lines of text all at once, and lots and lots of different cells, it wouldn't perform well at all if every time one went off, you destroyed that table view cell and created a new one for the one coming on. So what we end up actually doing is when a table view cell goes off the top, it gets placed in a queue for reuse. And in your table view self-array index path method, you have the option, and certainly, really, you should always do it, the opportunity to ask the table view for one of the cells in the reuse queue before you allocate a new one. So if one's already been scrolled off the top, it's not needed anymore for displaying what's currently visible. You can get that, change the content to whatever the new row you're being asked about needs to display, and it'll get scrolled in on the bottom. So it effectively ends up looking like a waterfall, circular waterfall, where as things go up off the top, they're just reused and they come back in on the bottom with new content. So this saves on all the extra overhead of releasing and reallocating all the memory associated with individual table view cells and makes scrolling much smoother and faster. So let's take a look at what that's going to look like. We'll implement, we'll be using the DQ reusable cell with identifier method in order to get one of these reusable cells back. And it's going to look something like this. So our fully filled out table view self-array at index path looks more like this. The first thing you do is call, we need to get the table view cell. So we'll ask the table view to DQ a reusable cell with identifier. And identifier can be any string that you want, and it's unique to this particular table view. So in this case, we're going to ask for an identifier, myIdentifier. And we won't get into the specifics today of why you'd need multiple identifiers, but if you had different types of cells that, for instance, had different subviews in them, each of the different type of cell in your one table view might have a different identifier so that you can have reuse queues for each of the different types. But in this case, we'll assume we just have one type of cell, and its identifier is myIdentifier. So if the table view had one that could be reused, it's going to return that to us, and it'll already be auto-released, so we don't have to do anything else there. We've got an auto-released cell, we can fill out its data and just return it. If it returns nil, which is perfectly valid, it may not have a reusable one for us to use. So if cell equals nil, we're going to allocate a new one. In this case, we'll allocate a new UI table view cell. We don't have a subclass right here, so we'll just allocate that. And the default designated initializer for UI table view cell, which we'll see in a bit, is init with style reuse identifier. So we'll call that, again, passing the same identifier that we used in the DQ. Those things have to be paired or it defeats the whole reuse purpose here. The idea is that you create a cell with a reuse identifier, and then you ask for DQ a reusable one with the same identifier. In both cases, we'll set the cell as text, and then we'll return the cell. There's actually, the one thing that's missing there is, actually, let's just edit the slide now before we screw anyone up here. I'm not sure how this disappeared. This should actually say auto-release. So, oops. The thought here is, as I mentioned, DQ reusable cell with identifier returns an auto-released object. So if we took that code path, if we just went cell, got back a reusable cell, that thing would already be auto-released. When we returned it, we'd be returning an auto-released object. We hold no retain counts on it. When we go through here, we want to make sure we do the same thing. So if this returns nil, our cell's nil, we want to allocate a new UI table view cell. So we've called UI table view cell alloc init. We now have a +1 retain count. We need to decrement that before we return it. But if we just released it, it would go away and we'd crash. So we want to auto-release it so that we clean up all of our retains on it and hand it back to the table view to do the rest of its memory management with it. So we need that last auto-release on there. All right, so that's what it's going to look like when you're creating and setting it up. How do you trigger an update? Say you get some new data in your model and your controller needs to have the table view display this new data. How do we get that to happen? So you may not actually have to. If the data comes in right away and it's not updated throughout the runtime, you're probably okay. The data source will actually not, the table view won't ask its data source for the data until it's first displayed. So if you had all your data available when the application launched, you probably never need to reload it. If something if some new row becomes visible, at that point, the table view is going to ask for the data for that new row, and you'll have to create this new cell or dequeue a reusable one and return that. If the entire content of your table view changes, if you just get entirely new data and just need to start over, reload everything, there's a method called reload data on UI table view. So for example, if we're in a UI table view controller, we can call self.tableview and call reload data, which will tell the table view everything you've got is invalid, put all of your cells in the reuse queue, and just start over. Ask me how many sections there are, how many rows in each section, ask me for all the individual rows again. It reloads everything. It's a pretty big hammer. If you know, for instance, that you just have new data for 2 rows, or you got 1 new row and you lost 1 row of data, you can be a little bit more specific about this, and in the process also get some nice animations. So for example, if you had 10 things in your array and you wanted to delete the first one, you can actually have that animate out and the rest of it animate up by using some more specific methods that can reload just parts of the data without actually throwing everything away. So the first one is insert sections with row animation. That can insert an entire section. And then delete sections with row animation, which can delete an entire section. And new in iPhone OS 3.0, we've got reload sections with row animation, which is effectively just a delete and an insert paired together, but added in one call. So you can basically tell the table view everything in this entire section is now invalid, throw it away and reload it, ask me about it again. Similarly, we have the same thing for particular rows. There's insert rows at index paths, which takes an NS array of NS index paths to be inserted. Delete rows at index paths to delete particular ones, and then reload for reloading an array of index paths. There's some additional data source methods that allow you to do some other things, like set up those section headers and footers that we talked about. The table headers and footers are properties on the table view. You just assign those views. Section headers and footers are per section, and so they're provided through delegate methods. I'm not going to talk too much about that. You can see it in the header for the UITableView.h has the UITableView data source protocol. And there's also some methods that allow for editing and reordering of cells. So if you've seen the stocks application, when you flip it over on the back, there's the array of stocks. You can actually change the order of those. There's a little grabber on the right-hand side that lets you reorder them. That's standard behavior provided by UI TableView that you can use yourself in your own apps. There's methods on the data source and delegate for dealing with that. And also for editing. Editing is in Mail, when you hit the edit button, the content of your cell slides over and little delete buttons move in. That's standard behavior as well. You can enable it and decide whether it's a delete button or or a plus button, using different data source and delegate methods. We won't talk too much about those, but if you want to use them, they're very well documented, and you can find them all in the headers. So that's how you get data in. That's how you're going to display your data. But what about the appearance and the behavior of your cells? So that's more the realm of the UI TableView delegate protocol. The data source is really all about providing data to the table view. The delegate is really all about customizing appearance and behavior. So again, keeping the logic separate from the view. We've got this one class, UI TableView, that we can use in all these different places on our iPhone because we've kept the specifics of the appearance of the views in the controller classes and left the more basic parts in the view. So we allow UI TableView to do all the basic stuff, but then hand off through the data source and delegate protocols some of the more specifics of doing customization. Often the same object is the data source and the delegate. In fact, it's pretty infrequent that the data source would be anything other than the delegate. And to be honest, I can't even think of a good example off the top of my head of why you'd do that. So for the most part, your data source and delegate are probably the same object. But they don't have to be. They could be different things. So how do we customize table view appearance and behavior? So there's quite a few methods on the table view delegate that allow you to do different customizations. We'll just talk about this one right here. Table view will display cell for row at index path. This is called immediately before the table view makes one of its cells visible. So it's basically your last opportunity to customize the appearance of the table view cell before it shows up on screen. It's guaranteed that once you've called this, we're not going to be mucking with any of the appearance of the cell itself afterwards. Anything you change in there, you can change it and it's going to appear on screen. So if there's something you maybe didn't know in your table view cell for row at index path method, you want to do a little more lazily, this will be called after that and give you one last opportunity to modify the appearance before it shows up. And also you can validate and respond to selection changes at this point. Sorry, not at this point, using the table view delegate methods. There's different methods for selection. When your user, this is actually a pretty common paradigm throughout many of the iPhone applications, right? You've got an array of, you've got a table view showing a list of items. User taps on one, some new thing slides in on your navigation controller probably. So the way you find out about that is table view will select row at index path and table view did select row at index path. These methods are called when the user puts their finger down and when they lift it up. The did select is called when the user lifts to indicate that the action has actually been performed. They didn't then start scrolling and cancel the selection. They actually selected that row. And so in your did select row at index path, you may decide to allocate a new UI view controller and push it on self.navigation controller, so some new thing slides in. Row selection is usually, as we just said, something that's going to trigger an event. It's pretty infrequent that a row is actually going to stay selected. Selection in a UI table view, unlike selection on NS table view or really most other desktop equivalent type objects, tends to be, on the desktop it tends to be more of a persistent thing. You would select an object and then perform some operation on it. On the iPhone OS with UI table view, selection is generally not a persistent thing. It doesn't usually remain selected after you've tapped it. You usually fade the selection out and perform an action, or you slide it off screen and then fade it out when it slides back. So an example of that, oops, went a little too fast there. Example of what we were just talking about, user taps on some item in their table view and we slide some new thing in on the navigation controller. So there are a couple of places where you'll find persistent selection used in some of the Apple-provided iPhone apps. Just two examples of that are the voicemail and voice memos application. These are kind of exceptions to the standard rule. It is supported now officially in iPhone OS 3.0. We do support persistent selections in table views. If your user selects a row and you don't deselect it, we won't deselect it on you. In the past, in iPhone OS 2.0, that didn't fly. If you didn't deselect it, the behavior was not guaranteed. We now do support this behavior. So if you have some kind of interface that looks something like this, or a place where you really think that persistent selection is just, it's necessary to indicate something to your user, we can do that now. So how do you respond to selection? We just talked about this did select row at index path method, and we kind of talked about what you might do with it already, but let's take a little look here. So first off, you're going to get the row out of the index path to figure out what it is that the user tapped on. We're going to get the object out of some array of objects, presumably. You could pretty much be storing your data any way that you liked, but in this case, we'll assume we have an array of objects. We're going to create a new view controller, so we'll allocate a new UI view controller, and probably have UI view controller alloc init with my custom object and pass that object in, and or we can set it on an accessor, and then we'll get self.navigation controller, so we'll get our current navigation controller, and push that new view controller and probably animate it so that it slides in and the other one slides out. So yeah, let's skip that. We're kind of low on time. Not too exciting or interesting. As I mentioned, there's another view controller, UI table view controller. It's a subclass of UI view controller, and it creates a UI table view for you. So it deals with some of the specifics of creating and setting it up. It sets itself as the delegate and data source of the table view that it creates. So you can, if you just subclass UI table view controller, you can just begin implementing these data source and delegate methods that we talked about without really doing anything else. It's already all set up to do all that for you. It's a pretty convenient starting point if you intend to use sort of a full screen table view style thing, the kind of stuff that Mail does, where you've got an entire screen that has pretty much just a table view. As I said, the table view is automatically created, controllers the table view's data source and delegate. It calls reload data for you the first time it shows up. It deselects rows when the user navigates back. So you kind of saw that in that video. If you weren't paying close attention, I'm sure you didn't notice because we went through pretty quick. Basically, the idea is if you have a row, say we're in Mail and we've got our list of messages, we tap on one of the messages and we navigate to that actual message. It slides in. When the user hits the back button and we slide back to to that UI table view, the row is still selected while it's sliding in, and actually you'll see it fade out as it's sliding in. So it gives the user some context about where they came from. It's a pretty important part of the whole continuity of the experience for them. As they're hitting the back button and going back, they have this visual indication of what it was that took them to where they came from, where they're coming from. And so UI table view controller takes care of doing that deselection at the right time for you. It also flashes the scroll indicators. This is actually part of the iPhone OS human interface guidelines, is when a new screen becomes visible that has a table view in it, or any scroll view actually, the scroll indicators should flash once, again to give the user some context about what it is they're seeing, and so they have some idea of how much scrollable area is left on what they're seeing. Table view controller does that for you, so you don't have to worry about conforming to the interface guidelines. It helps you with all that. It actually does one other thing that is not very commonly known, probably. If you have a table view that has an editable text field in it, so say you've got some text entry inside of one of the rows on your table view, and you tap on that editable text field, a keyboard is going to slide up. That's standard behavior. That would happen no matter what. But table view controller, one of the nice things that it does for you is it'll make sure that once that slides up, the text field that you were editing gets moved up to be visible. So it won't get covered by the keyboard, even if it was down at the bottom of the screen. And it also makes sure that it adjusts the content insets that we talked about earlier when we talked about scroll views, so that there's an amount of extra padding at the bottom of the table view that is equivalent to the amount that the table view is obscured by the keyboard. So basically, it makes sure that that even though you've now got a keyboard up and some of your table view is covered, all of the content still remains visible. Or not necessarily visible, but scrollable. If you scroll all the way to the bottom, you can still see everything. Nothing's stuck behind the keyboard. So that part is actually probably one of the most beneficial parts of UI Table View Controller. The other pieces, the flashing scroll indicators and deselection, they're things that are pretty easy to implement in any case. The behaviors dealing with the keyboard are quite a bit more complicated, and I definitely encourage you to use UI Table View Controller if you can make it fit in your designs and you're using table views. So table view cells, those are the things that are displaying the individual rows. I think we're running a little low, so try and get through this pretty quick. As I mentioned, actually, this is the old designated initializer, table view table view cell init with frame reuse identifier. If you happen to be looking through sample code on the internet or some old documentation, you may still see this around. That's no longer our default initializer for UI table view cell. So if you see it, it still works. You can still call it. The frame is ignored, so it doesn't provide a whole lot of benefit. The frame is going to be set by the table view when it's actually positioning it in the table view. So the new designated initializer is init with style reuse identifier. And you can actually pass one of the new iPhone OS 3.0 UI table view cell styles in your initializer now, along with the reuse identifier. So the cell styles. The default one is UI table view cell style default. And that gives you just the single line of text that you're used to seeing maybe in, a lot of our applications, like the address book. It can also display an image. If you set an image, it'll display to the left of the text. There's also UI table view cell style subtitle, which will look like one of these two things, depending on whether you've provided an image or not. The difference really between this and the default one is that it has room for a subtitle. So if you set a title and a subtitle, you'll get something that looks kind of like that. It handles setting the colors for you. So you'll look just like the default applications that are provided as part of iPhone OS. In this case, this is an example of what it looks like in the media player application, or the iPod application. Another of the styles we have is UI table view cell style value 1 and value 2. They're very inventive names. These are pretty much intended to be used with group style table views. You'll see these used mostly in the settings app on the iPhone. And really, they really are designed to be used in the group style table view. You could use them in a plain style, but they may not really look that great. They're really designed for group style. And so they'll look like this. They'll have a main label or on either the left or right, depending. Actually, I guess it's always on the left. And then a bit of extra information on the right. Table view cell has a couple basic properties to display these things. The first is it has an image view, which is just a UI image view, but you can access it through cell.imageview. And in this case, we're going to set an image on that image view's, give that image view an image, which will give us that thing on the left. It has a text label. All of the cell styles support a text label, all the ones before we just saw. The last three we saw, the detail text label, sorry, I forget the names already. Come on. So the cell style subtitle and cell style value 1 and 2 also support this detail text label in addition to the regular text label. For the subtitle, the detail text label is the subtitle. For the other two, it's the actual value. If you set a detail text label's text on a default style table view cell, it just won't do anything because it doesn't display an extra detail text. There's a couple of accessory types that you can set on table view cell. That's the thing that appears over here on the right-hand side. In this case, it's table view cell accessory disclosure indicator. This is generally used to indicate that if the user taps on this cell, some new thing is going to navigate in. That's usually what you use that to indicate. And you set these by implementing the delegate method table view accessory type for row at index path. So you can have different accessory types for each of the cells in your table view. Another example of one of these is UI table view cell accessory detail disclosure button. And that gives you that kind of blue looking thing over there. The idea with this one is usually that you'll have an operation performed. Usually you'll get more information, you'll usually view a piece of content as a result of tapping the cell itself. So if the disclosure is there, usually it means to the user tapping the cell will display this content. Tapping the blue disclosure indicator will show more information about this content. You can see this in the iPod application. When you tap on the cell itself, it actually plays the video. When you tap on the disclosure indicator, it slides in a new thing on the navigation stack that shows you more information about the video. And there's actually another method that you would implement if you're using this called table view accessory button tapped for row with index path. A little bit of a mouthful. Which basically tells you which index path the user tapped the accessory button for. And finally, we've got UI table view cell accessory checkmark, which gives you the checkmark. It basically lets the user pick one out of a list of things in their table view. And I think we're just about done here. So let's just real quick. I mentioned that you actually have more customization options in your UI table view. UI table view cells are just a subclass of UI view, so you can customize them the way you customize pretty much any other UI view. The one thing that's special about table view cells related to this is that all customization in the UI table view cell is generally done to the content view of the UI table view cell. So table view cell has a content view method. In this case, you can see here we're getting cell.contentView.bounds, and then we're going to position some subviews relative to that. So we're going to allocate a new UI label, init with frame. In this case, frame is going to be the content view bounds, so it's going to fill up the entirety of the content view. And we'll set its text. We'll get cell.contentView, which is this view that we're going to customize, and add the label as a subview of that. Generally, you don't want to add subviews to the table view cell itself. You want to add them to its content view. And the reason for that is that as you're doing things like using editing mode and reorder in the table view will automatically shrink the content view of the cells to fit the available space. So if you enter editing mode, the content view is going to shrink and move to the right to make room for those delete controls. So if you've put all your content in the content view and set up your springs and struts correctly, you won't have to do any extra work when you enter editing mode. Everything will just move and relay out to fit in there correctly. The last thing I wanted to say real quick is that in iPhone OS 3.0, we actually support embedding one scroll view inside of another. So you can kind of see this in our app launcher and the Spotlight view. You can have this horizontal scroll view, and you can page horizontally through it. And then you might also have a table view inside of one of those pages where you can scroll vertically. This is supported default out of the box. If you just create two scroll views and put one inside the other, it just works. You probably want to stick with scroll views that scroll on different axes. So like a horizontal one embedding a vertical one, or a vertical one embedding a horizontal one. It will kind of work if you put two in with the same axis, like a vertical inside a vertical, but the behavior is still not guaranteed to remain the same. We may change that in the future. So it's pretty cool, though, to be able to do these horizontal and vertical ones, and we use it a lot. So if you're coming up with new interface ideas, it's an interesting thing to do. So thanks. Any questions? I know it's kind of late. Okay. Thanks, guys.
For more, please visit us at stanford.edu.